So since functions can be given in a variety of ways, I'm going to go ahead and break up the lecture into functions as tables, equations, and graphs. So we're going to be looking at finding the limit of a function when your function comes in the form of a graph. So first of all, let's review what a limit is. So let f of x be a function defined at all values in an open interval containing a. So let me go ahead and define that for you. So open interval, right? So between some x of 0 and x of 1, right? Parentheses make it open, so not necessarily including. And then a is another x value. So f of x is defined on this chunk of x values, with a possible exception. Okay, so that was me and my exception of a itself, and let L be a real number. Okay, so so a is an x value, and we're just saying that f of x is defined, so you don't have any big old chunks of graph missing. X is defined in the region containing a, containing x equals a, okay? And then L is just some number. If the values of the function f of x approach the real number L, so now the values of the function, so the y values approach L as the values of x approach a, then we say that the limit of f of x as x approaches a is L. Should have made those a's be a little bit different when approaches a. So these are the value x equals a. Okay, so more user-friendly form. As x approaches a, f of x approaches L. Okay, so symbolically, this is what we're going to write, and you're going to get very good at writing this. So the limit, and then down below a little bit, we write as x, and use an arrow, approaches a, of f of x equals L. And that just means, as x gets close to a, y gets close to L. Okay, so that's what it's going to look like. That's right, we're going to be looking for those values of L. What does it look like our y values are doing as x gets close to a? And then before we get into those, I want to let you know that we might also find one-sided limits. So what that's going to mean, so we can approach from the right. So we're going to, the way you can think about it is hop on the graph, to the right of a, so to the right of x equals a, and walk to the left. So approaching from the right means you start on the right-hand side and you go in towards a. So the way we write that then, to say, hey, I mean the limit from the right, we say the limit of f of x still, but then it's x approaches a, and I don't know if you can see that, but there's a little superscript on the a that's a plus sign. So the little plus that's superscript of the a means from the right. And the fact that this x approaches a is down below the limit and not over to the side was just spacing. It can go either below or right in between like I have here. It doesn't really matter. So then likewise, approaching from the left, we're just going to swap those things, so opposite. So approaching from the left means you're going to hop on the graph to the left of x equals a and walk to the right. So approaching from the left. So you start on the left side and go to the right. And then, of course, that would be the minus sign. That's the superscript, so from the left. Okay, so we're going to practice all of those, and I have a completely ridiculous graph right here. Notice it is following all of our function, well, the vertical line test function rule. So here at -2, you'll see I've got an open circle above and a closed circle below so that I'm not double defined. Okay, so the first one we have here, the limit as x approaches 0 of f of x. So this is an x value, so we're going to look in the vicinity of x equals 0 and try to see what does it look like our function is doing. So here's right where x equals 0, and we're going to get on our function. Well, there's not much going on there. It just looks like our function value, our y values, are close to 2. -2. Sorry, I said -2. Okay, let's try the next one. What's the limit as x approaches -4? So again, we're going to look where x equals -4. It's right here. Right? It's the same from both sides, so I don't have to worry about that. And what does it look like our function value is doing? Well, if x is -4, it kind of looks like our function value is, what is it? How about -0.6? -0.6. Just sort of estimating there. How about this one? What's the limit as x approaches 5? So you go to where x equals 5, go up and look on your graph. That looks like the y value is approaching 5 as well. So unless you've got a big old gap or a jump or something, right, the limit, right, is just the y value there. So how about this one now? So now we're going to do a one-sided limit. What's the limit as x approaches 1 from the left? So I'm going to go to where x equals 1, and this time I'm going to come in from the left. So I'm going to hop on my graph to the left side of x equals 1, and I'm going to walk towards 1. What does it feel like my graph is doing? What are my y values doing there? Okay. So they are staying nice and steady at -2. Now, right? Exactly. So let's do that one. So the limit as x approaches 1 from the right, with that little plus sign there. So now I get on my graph to the right of 1, and I'm going to head towards 1. And so now I'm walking to the left, towards x equals 1. What is happening to those y values? Okay, now I don't really, it's kind of challenging. I'm not really interested in what happens exactly at x equals 1. I just want to know, how is f trending? What is it headed towards? Right? And it's headed towards a y value of -3. Okay? So even though that's not what it actually equals at x equals 1, that's what it's tending towards as we approach x equals 1 from the right. Right, we're going to have a whole lesson on continuity and what conditions we have to have for that. But what we're looking for now is just what is the limit, what is f, what are my y values getting close to as x goes in a certain direction. Right, so you might see we could do the same thing over here at x equals -2, so should we practice writing those? So what's the limit as x approaches -2 from the right of f of x? So if you're approaching from the right, you hop on the graph to the right of this x value that I've given you. And so here's x equals -2. We're going to hop on our graph, our function, on the right side of that and head towards x equals -2. So the y value there, -2. And then if we head towards -2 from the left, so x approaches -2 from the left, the little negative superscript, and right, and we're talking about our function f of x, what is that value? So we're headed towards -2 from the left-hand side. Walk that way. It looks like my y values are getting closer and closer and closer, right? The closer I get to -2, the closer my y values get to 4. So that's how you can use a graph to evaluate the limits of a function.